This is 2.6, similar figures. A similarity transformation is a dilation or a sequence of dilations and rigid movements. Similar figures are when one figure can be obtained from the other by a similarity transformation. So similarity transformations make similar figures. Similar figures have the same shape, but not necessarily the same size. And their side lengths are proportional, angles are congruent. So the measures of the angles are the same. I can see this in looking at these two triangles. They're different sizes, and the markings on the angles show that they are congruent. So A is congruent to D, B is congruent to E, and C is congruent to F. Then I have side lengths. AB is proportional to DE, BC is proportional to EF, and AC is proportional to DF. They are the corresponding sides. If your triangles are in different orientations, like if one is more up and one is more sideways, you would use the angles to see what are their corresponding sides. Or if it's clear to see which one is the hypotenuse, which one is the smallest side, you would do it that way. So we're going to determine whether the figures are similar. So if I'm given these, I need to, it looks like their angles are the same, but are their sides proportional? So I'm going to take A is the point 03, and 0 times what makes 0, 3 times what makes 6. So to get, and then B, I would have 3 and 3 each multiplied by, they're all going to be multiplied by the same thing, because we need to see, is this a dilation? And these are the points that I will end with. So for each of these, to go from 3, 3 to 6, 6, that's multiplied by 2. 3 to go to 6 here, also multiplied by 2. So if I use a scale factor of 2, I go from ABC to DEF, and so therefore this is a similar figure. Now we are told that these two figures are similar, and we're going to describe a similarity transformation between the two. So to know some points here, if I start with the teal, this is a 1, 2, 3, 4. It is a quadrilateral of some kind. I'm going to start here and move to the orange. So it looks like it's upside down and the orange is larger. So if I reflect it in the x-axis, I will end with this dotted figure with a couple coordinates pointed out, and then I need to make them into the coordinates that are given here. So that is a reflection, and then we're going to dilate that reflection. So we're going to go from 3 to 6, multiply by 2, and then to go from 2 to 4, we'll also multiply by 2. So scale factor is 2. A replica of a painting is made. The painting contains a trapezoid. The replica has a shorter base of 3.75 inches and height h. What is the height of the replica? So I need to use the information that I'm given to be able to find the height. So I'm going to have to make a proportion and solve for the missing piece. So this trapezoid, the shorter base is 3.75. We are given the original, and I need to find this height. So I know that in similar figures, their side lengths are proportional. So I put original over replica, original over replica. And this is base over base, height over height. So original is across the top, replica is across the bottom, base is on the left, heights on the right. And then I will cross multiply and solve for h. So 15 times h and 12 times 3.75. Divide each side by 15 to get h is 3. So the height in the replica is 3 inches.